Hello, everyone. Welcome to Conf42 Cloud Native 2025. I am Arun Pandiyan, a technology infrastructure specialist, and I am going to talk about how a unified multi-cloud monitoring solution can deliver comprehensive observability across diverse cloud service providers. So, in the agenda, I will talk about the importance of multi-cloud monitoring and then the core components of multi-cloud observability and what are the tools that can be integrated and deployed in multi-cloud monitoring, best practices that can be leveraged, and at last the future trends in observability. I will start with the complexities in managing multiple clouds. Organizations are rapidly adopting multiple cloud platforms to leverage their unique strengths, but they also inherit a set of operational challenges that can significantly impact their ability to monitor, secure, and optimize these multi-cloud environments effectively. First challenge is data silos and fragments. Each cloud provider typically comes with its own monitoring and logging systems or solutions. As a result, these solutions can create fragmented data and making it difficult to derive holistic insight without a centralized approach. The second is the latency and performance bottlenecks. So, the organizations collect or gather real-time data from globally dispersed networks, and those networking complexities can introduce service delays. The third one is compliance and security visibility gaps. So each provider offers distinct controls and default configurations. So uniformly enforcing security and compliance policies across all the cloud environments can be challenging. And at last, the scalability and cost management. The volume of the logs and metrics grows exponentially on a daily basis. So the expense of storing, managing, and analyzing the data can become complex. The next, I want to talk about the importance of unified multi-cloud monitoring. The first is we can achieve the consistent operational visibility. A centralized monitoring approach enable comprehensive visibility and understanding of what's happening within multiple cloud environments. So this holistic view makes it easier for teams to track performance trends, detect anomalies, and maintain healthy application or service levels. The next is this simplified incident response and root cause analysis. So whenever an issue occurs, it is essential to resolve it quickly to meet the MTTR metric, or the mean time to resolve. And the unified monitoring solution help us to consolidate logs, metrics, and events at one particular place to reduce the time spent on in analyzing the data. So this streamlined approach helps teams to identify the issues or problems quickly, drive resolution, and even avoid prolonged service disruption. The next is the enhanced reliability and infrastructure resilience. So if by continuously monitoring or tracking the key performance indicators, the KPIs, we can proactively fix issues before they become critical. So the insights that are gathered highlight the patterns or irregularities that help the team to intelligently scale decisions on auto scaling and then also support the preventive maintenance. And next one is the streamlined security and compliance monitoring. So the security and regulatory requirements can become complicated when multiple cloud providers are involved. So a unified view is required to help standardize the monitoring practices across all the cloud platforms and detect suspicious activities instantly and meet the compliance requirements. And at last, the cost optimization and resource efficiency. So the multi-cloud monitoring solution offer comprehensive visibility into cost and resource consumption that allows teams to make informed decisions about the capacity planning, cost allocation, and optimization approaches. And the next, I will go over the core components that are involved in a multi-cloud observability solution. The first one is the data collection. Here we can aggregate the log, metrics, traces from diverse cloud environments and utilizing agent-based or agent-led solution to capture every critical event. So this continuous stream of raw telemetry data that supports the analysis and also support to create a robust observability solution or system. The next one is data processing and correlation. Here, if we use the advanced analytics, machine learning, and even correlation, we can transform the data into context-rich insights by identifying the patterns, anomalies, and dependencies across distributed services. So this refined data set gives teams the ability to diagnose issues quickly, accelerate the root cause analysis and decision making in complex multi-cloud landscapes. The other component is observability and visualization. So with interactive dashboards, health checks, and alerting capabilities, so we can achieve the real-time visibility into application performance and infrastructure status. So these unified views help teams to spot trends, isolate bottlenecks, and maintain seamless service or application delivery by showcasing the system's relationship and dependencies. The next is automated remediation and instant response. So whenever the anomalies or threshold breaches occur or detected, automated playbooks or self-healing mechanisms are enabled. So that helps us to resolve issues before they escalate. So this integrated incident response mechanism or approach ensure minimal downtime by orchestrating the alerts, on-call schedules, and collaborative workflows for rapid problem containment. And at last, the security and compliance monitoring. So we can continuously scan the telemetry for suspicious activities or policy violations, reinforcing proactive threat detection and compliance adherence in multi-cloud setups. So through seamless integrations with security frameworks and automated compliance checks, teams can uphold a stringent governance, mitigate risks, and satisfy the regulatory requirements. There's a reference or a sample architecture that can be even used to design a unified monitoring system for multi-cloud environments. So the first layer is data collection layer. The monitoring solution can support multiple cloud environments, including major service providers, AWS, Azure, Google Cloud, and even private cloud. So each cloud provider generates logs, metrics, and events that need to be monitored for performance, availability, and security. The next is the monitoring agents. So the agents are deployed across different cloud environments to collect the observability data. So these agents gather log, metrics, and even data from various cloud native services and infrastructure components. Then next is the data aggregation layer. Here the data is categorized, like the observability data is categorized and processed by specialized components like log collectors that handles the logs generated by the applications, infrastructure, and cloud services. And the other one is the metrics aggregators. Here it processes and normalizes performance related metrics. The last one is the event stream processors. This helps manage and analyze event-driven data streams for real-time insights. And the next one is centralized monitoring and analytics. So all the collected and processed data is sent to a centralized monitoring and analytics platform. So this layer is responsible for correlating different types of data, detecting anomalies, and even identifying the patterns for proactive monitoring. The second last is the observability and alerting mechanism layer. So these layers generate alerts based on anomalies, security breaches, or failures, system failures. So they help create a real-time dash for visualizing the system health and trends. And at last, we have the incident management. Here, the alerts from the system are fed into ITSM tools for ticketing and incident resolution. Here, the next I'll talk about the tools that can be integrated or deployed in multi-cloud environments. First, either we can use the open source tools or like commercial SaaS platform tools. So open source tools such as like Prometheus, Grafana, Jagger, OpenTelemetry, and SaaS platforms are Datadog, New Relic, Grafana Cloud, Dynatrace, Splunk. In terms of deployment, the open source tools require manual setup, configuration, and maintenance, but the SaaS platforms are fully managed or completely managed by the service provider. It is also easily quick to deploy and scalable. Also, in terms of scalability, open source tools are horizontally scalable, but requires careful planning of capacity and resource allocation. But for SaaS platforms, it is automated, elastic scaling, and also it supports elastic scaling in response to resource usage, and the vendor handles the capacity planning. For the cost-wise, open source tools are typically free, with costs rising from the self-hosting infrastructure or storage, compute, networking, and even the maintenance and the scaling cost grow with the usage. And also the SaaS platforms cost is subscription based. Cost can increase with the data ingestion and storage. Next is the best practices that we can follow for implementing robust, unified, multi-cloud monitoring solution. Yeah, first we can define a centralized observability strategy to establish a unified observability framework that consolidates the logs, metrics, and traces from all the cloud environments. And next, we can adopt a multi-layered data collection approach to collect telemetry data across infrastructure, applications, and network layers. And we also can normalize and correlated data across cloud environments to standardize the diverse data formats and even under correlate the metrics, logs, and traces to create actionable insights and prevent any blind spots. We can also implement a vendor agnostic observability platform to integrate seamlessly with the cloud service providers to avoid any vendor lock-in. And it is possible to embed observability into CI/CD workflows for proactive monitoring, automated anomaly detection, and even faster incident resolution during any critical deployments. Also, we need to strengthen the security and compliance monitoring to safeguard the workloads or any application deployments across multi-cloud environments. So the last, I'm going to talk about the future trends in cloud monitoring and observability. The first is the AI-driven observability and anomaly detection. So many organizations leverage some AI-driven solutions like AI-powered analytics and machine learning models for transforming the observability by automatically detecting anomalies, predictive failures, and even enabling some self-healing capabilities in multi-cloud environments. The next is the observability in the serverless and edge computing. If when the workloads shift to serverless architectures and edge computing, observability solutions should evolve to provide real-time visibility into these sort of ephemeral resources and highly distributed environments. The next is the eBPF and the kernel level monitoring. This is mainly applicable for the Linux operating systems. So eBPF is revolutionizing the cloud monitoring by enabling deep, lower visibility into calls, network activity, and application behavior directly at the Linux kernel level. The next is the shift level observability for DevOps and SRE. So if we apply observability early in the software development lifecycle, so it allows DevOps and SRE teams to proactively detect issues, optimize the performance, and even ensure the reliability from the beginning, reliability of systems from the beginning. And at last, the security-driven observability, that's a COPS plus observability. So this allows cloud security teams to integrate security insights into observability pipelines to enhance threat detection, compliance enforcement, and proactive risk management across cloud native applications. Thank you.